Right now, as you watch this video, something extraordinary is happening in southern Italy that most people will never witness. While 500,000 residents of Naples and Pozzuoli sleep in their beds, just 3 kilometers away, the ground beneath Solfatara crater is glowing brilliant orange in complete darkness. But this isn't lava. This isn't an eruption. What thermal cameras are capturing at midnight is something far more revealing and potentially more dangerous. For the first time, scientists at Italy's National Institute of Geophysics and Volcanology have documented a pattern in these nighttime thermal signatures that preceded a magnitude 4.4 earthquake by exactly 3 days. The orange glow you're about to see isn't just beautiful. It's a warning system written in heat and gas, broadcasting signals from 3 kilometers underground. And here's what should keep you watching. In the past 72 hours, that glow has intensified. Campi Flegrei isn't just any volcano. It's a supervolcano caldera, 24 times larger than Mount Vesuvius. And it sits directly beneath one of Europe's most densely populated urban areas. But unlike Vesuvius, which advertises its danger with our iconic cone visible for miles, Campi Flegrei hides in plain sight. The crater looks like a peaceful amphitheater. Tourists walk its trails during the day, photographing yellow sulfur deposits and steaming vents. But when the sun sets and those tourists leave, a different story emerges. INGV, network of 5 permanent thermal imaging stations, switches on, their lenses capturing wavelengths of light invisible to the human eye. These aren't ordinary cameras. They're FLIR R645 ST thermal sensors, military-grade equipment capable of detecting temperature differences of just 0.03 degrees Celsius from over a kilometer away. Every night at midnight, 2 a.m. and 4 a.m., these cameras record the true face of Solfatara, a face that daylight conceals. What they've discovered is changing everything volcanologists thought they knew about early warning systems. Let me show you something that's never been explained to the public in detail. The main fumarole at Solfatara, called Bocca Grande, which translates to Big Mouth, has been exhaling superheated gases continuously for over 2,000 years. The Romans knew it. They built temples around it. They called this place the Forum of Vulcan, the forge of the god of fire. Today, INGV measures its temperature every single day. The current reading is 164 degrees Celsius, that's 327 degrees Fahrenheit. Hot enough to melt lead. Hot enough to boil water 3 times over. But here's what's crucial. 10 years ago, that same vent measured 160.7 degrees. It's been rising. Not dramatically, not in a way that makes headlines, but steadily, relentlessly, in a pattern that correlates exactly with something else happening underground. 25 meters away sits a second major fumarole called Bocca Nuova, the new mouth. But while Bocca Grande heats up, Bocca Nuova cools down. Its temperature dropped from 149 degrees to 146.6 degrees over the same period. Why would 2 fumaroles, sitting barely the length of a basketball court apart, fed by the same deep magmatic system, behave in opposite ways? The answer reveals the hidden architecture of what's really happening 3 kilometers beneath your feet. And that architecture, that underground maze of fractures and gas chambers, is what the nighttime thermal cameras are finally allowing us to see. But before we dive into what scientists discovered down there, you need to understand something critical about why nighttime monitoring changed everything. And why. What happened on May 17, 2024, sent shockwaves through the global volcanology community. Here's something most people don't realize about thermal imaging. During the day, the sun heats everything. Rock surfaces, soil, metal railings around the crater. Even the air itself radiates infrared energy that overwhelms sensitive cameras. It's like trying to hear a whisper in a crowded stadium, they said. But at midnight, when temperatures drop and solar radiation disappears, those cameras can finally isolate the true heat signature coming from deep underground. The difference is staggering. Daytime thermal images show surface temperatures of 30 to 40 degrees Celsius. Nighttime images reveal hotspots of 160 degrees, concentrated in specific areas that correspond exactly to fracture zones mapped by seismic tomography. For 20 years, from 2004 until today, INGV has been capturing 3 images every single night. That's over 22,000 thermal snapshots per camera station. On May 14, 2024, the S-Phone thermal station recorded a 5 degrees Celsius temperature spike at Bocca Grande. 5 degrees might not sound like much, but in a system this stable, it's enormous. The automated alert system flagged it immediately. INGV volcanologists reviewed the data, cross-referenced it with seismic stations, and waited. 72 hours later, at 3:27 a.m. on May 17th, a magnitude 4.4 earthquake struck directly beneath Pozzuoli. It was the strongest quake in the current unrest episode. Buildings shook. Car alarms screamed across the city. Families ran into the streets in their night clothes. And when scientists went back to analyze the thermal data, they found the same pattern had occurred before previous major quakes hidden in the archive, unnoticed until now. The orange glow intensifies. The underground pressure builds. Then the Earth releases. This discovery fundamentally changed the monitoring protocol. Now I want you to think about this carefully and drop a comment with your honest answer. If you lived in Pozzuoli and scientists told you a thermal camera detected a 5-degree spike 3 days ago, would you evacuate immediately, or would you wait for an official warning? Remember those 2 fumaroles I mentioned? Bocca Grande heating up while Bocca Nuova cools down. Scientists finally solved that mystery using electrical resistivity tomography, essentially giving the underground a medical CT scan. What they found was shocking. Both vents connect to the same gas reservoir 60 meters underground. A chamber the size of 10 Olympic swimming pools, filled with superheated steam and volcanic gases at extreme pressure. But the conduits, the pipes connecting that reservoir to the surface, are completely different. Bocca Grande has a wide, straight conduit 5 meters in diameter. Gas flows directly upward with minimal interference. Bocca Nuova has a narrower, more tortuous conduit only 2.5 meters wide. Condensed steam, essentially underground water vapor, mixes with the rising gases and cools them before they reach the surface. It's the same source, but different plumbing creates different temperatures. And here's why this matters for the nighttime glow. Bocca Grande's direct connection means its thermal signature reflects real-time changes in the deep reservoir pressure. Pisciarelli sits just outside Solfatara's eastern rim, and its nighttime thermal signature tells a completely different story. The temperatures here are lower, between 95 and 110 degrees Celsius, but there's far more liquid water in the system. This creates something volcanologists call phreatic explosion risk. On January 7, 2013, after 3 days of heavy rain, residents heard a sound like a cannon blast at 2 a.m. They ran to their windows and saw a column of boiling water and steam shooting 5 meters into the air, illuminated by streetlights, looking like something from another planet. The geyser lasted 40 seconds. When scientists arrived at dawn, here's my question for you, and I genuinely want to know your answer in the comments. If you heard that cannon blast sound at 2 a.m. and saw steam glowing in the darkness, would your first instinct be to run toward it, to film it? or run away from it. So why does Solfatara glow orange at night when there's no molten lava? The answer is pure chemistry. Those 164-degree gases deposit minerals as they cool at the surface. Under thermal cameras, these minerals radiate stored heat long after sunset, creating that eerie glow. But here's the terrifying part. All three of those minerals are highly toxic. A single breath of vaporized realgar can cause severe arsenic poisoning. What you need to understand is that Solfatara's orange glow isn't being watched by one camera or two. It's being monitored by an entire network that never sleeps. 5 permanent thermal stations surround the crater like sentinels. And Anton watches the entire caldera from Monte Olibano 3 kilometers away. Every single night for 20 years, these cameras have captured the crater's thermal heartbeat. That's 73,000 nights of data, 109,500 individual thermal images. And artificial intelligence algorithms have been scanning every single frame, looking for patterns invisible to human analysts. What they discovered should fundamentally change how we think about volcanic early warning. Temperature anomalies appear on average 4 to 7 days before significant seismic events. Right now, as you're watching this, 500,000 people live within the red zone of Campi Flegrei. They wake up, go to work, send their children to school, shop in markets built on ground that has risen 140 centimeters since 2005. That's 4.6 feet. Entire harbor docks now sit above water at low tide. Ancient Roman columns that were underwater in the 1980s are now exposed to air. The ground is literally breathing upward at 25 millimeters per month, and nighttime thermal monitoring is one of the few tools scientists have to distinguish between harmless uplift and dangerous pressure accumulation. In 1982, when uplift reached 9 centimeters per month, those thermal cameras asked the same silent question: is tonight the night the pattern changes? Here's what I need you to seriously consider, and please comment your answer, because this affects real evacuation planning. 164-degree gases rise through fractured rock, deposit toxic but beautiful minerals, and radiate heat that specialized cameras can detect from kilometers away. The glow's intensity correlates with underground pressure. Its pattern predicts seismic events. Its chemistry reveals what's happening in the magma chamber, 3.6 kilometers below. For 2,000 years, humans have watched Solfatara steam and wondered what it meant. For 20 years, thermal cameras have been giving us the answer, frame by frame, night after night. The Romans called it the Forum of Vulcan. Modern science calls it a natural laboratory. So the next time you see footage of Solfatara glowing orange in the darkness, remember, you're not just looking at a pretty volcanic phenomenon. You're looking at a warning system that took 20 years of continuous monitoring to decode, operated by scientists who watch those cameras every single night, so that 500,000 people can sleep peacefully. If this video changed how you understand volcanic monitoring, hit that subscribe button right now. Because we're tracking Campi Flegrei's every move, and the next thermal spike could happen while you're watching this channel.